talk about this IP address assignment, so we talk about so this IP address having certain part as network prefix, certain part as suffix. But when you talk about assigning an IP address is concerned, now the next question comes, how a IP address is being assigned to a system. That is another important aspect you have to understand very clearly. Okay, so for that sake, today I will discuss one important protocol which carry out the task that is called DHCP. This protocol DHCP, we'll talk about in detail today. By using this protocol DHCP, how the IP address assignment is happening to a system. Okay, so before going to talk about this protocol, let me tell some of the background so that you can able to understood. So why assigning an IP address is so important. Okay, see, can anybody think of how a IP address is assigned? Let's say when I talk about this IP address, I talk about the public IP address, because you already know what is a public IP address, what is a private IP address. Can anybody tell me what is the use of? So whenever you want to make a communication in the internet, that is the global network, so then you must have a public IP address. By using a private IP address, I can't able to make a communication in the internet or global network. So if I want to make a communication in the global network, that is the internet, then I must have a public IP address. When I talk about right now about this IP address, how a IP address is assigned to a system. So right now I'm talking about the public IP address. How a public IP address is, you are subscribing a network, maybe a Geo network, maybe a Reliance network, maybe a Airtel network. Okay, so there are several networks available. You have to go and subscribe to one network. So whenever you are going to get subscribed to a network, what you are doing? So your network is providing an IP address to your system. Okay, that means if I am using a Geo connection, so the Geo service provider, that is called as a ISP, Internet Service Provider. Geo, Airtel, Reliance, whatever you talk about, so these are all what internet service provider. If you want to communicate, or if you want to communicate in the internet, you have to subscribe so from this respective internet service provider. When you subscribe from this internet service provider, what do you mean by that? So that means ultimately this internet service provider provide you with some public IP address. Okay, they are providing you certain public IP address. Okay, that means ultimately you are paying money for getting certain public IP address. That's the ultimatum. You try to understand. So that means if I'm an individual, I'm paying for one only. If it is an organization, as an organization, I want to go for making a communication in the internet, I may have to buy several IP addresses, so I have to pay for it. So that means in that case, I may need a block of IP address. Okay, an address block I need. As an organization, I may need a block of address. As an individual, I may need a single IP address. So depending on the requirement, so the service provider is going to ultimately provide an IP address to all of us. Okay, that is the first thing we have to understand. If I want to communicate in the internet, I must buy a public IP address. How I do it? I do it from the service provider. Okay, but again, the next question is, so the service provider is not the sole owner of the IP addresses. Whatever IP address is being assigned to you, so this ISP are not the sole owner of it. So again, they are buying it from somebody else. They are paying money to somebody else to get these IP addresses. Who are them? So this ISP get the block of IP address from an organization or from an authority. So that is a government body, you can say. That is called as a ICANN. This is the background, just try to understood. So it will be interesting to understood why DHCP then. Okay. So that organization is called as Internet Corporation for Assigned Names and Numbers. So this is the authority or the body who is responsible for allocating the IP address. Ultimately, so this IP address is, we can say these are the owner. They are the owners of this IP address. Ultimately, they provide the IP address to the ISP. So then from ISP, ultimately at the end user, we get the IP address by paying certain money to the internet service provider. Okay. So this is how, basically we got an IP address. Okay. Now, so the next question is, once, let's say for example, I get a block of IP address. I want to set up one organization. I got a block of IP address. So I have set several computers. In this organization, I have several computers to associate IP address with. I got a block of IP address to associated each and every computer of mine. Okay, but now the question is, next question is, if I got a block of IP address, next question is how to assign a particular IP address to a particular system. A particular IP address has to be assigned to a particular system. So how to do it? So then there are two options available. So whenever we are going to get a range of IP address block, then to assign a particular IP address to a particular system, either I can go for assigning the IP address manually, or I can go and think of assigning the IP address automatically. There are two ways I can go and assign the IP address to my system. Okay, either manually you go and assign one IP address to a system. Okay, but if I do that, so what is the advantage? What is the disadvantage? Let's try to understand. If there are, let's say, 4 computers, okay, I can go and easily assign one IP address to each and every system, and that is unique. I can ensure that. But if there are 100 systems, if there are 1,000 systems, so in that case, whenever I go and assign the IP address manually, first of all, it is a very tedious job. It will be time taking, time consuming. So to go to every system and assign one IP address manually is very, very time consuming. So whenever the number of systems I need to configure is increasing or growing. So that is the first disadvantage if I go and do it manually. Second, another disadvantage, it may happen. So the same IP address, let's say X is the IP address I have assigned to this system. It may happen if I'm assigning 1,000 system with IP address, the same IP address I can go and assign to another system, because it is a human error. Human is to err. Okay, you can't deny that. So that means it may happen the same IP address wrongly assigned to 2 different systems. If this is going to happen, so then ultimately my communication is going to fail. So that's why these are the disadvantages if I go and assign the IP address manually to the system. If the number of systems to be assigned with the IP address is very, very small, it is okay to go with manual. But if we go for manual assignment, if the number of system grows, so then there might be a lot of difficulties I might face. Another important difficulty I might face. So let's say, for example, I am here. Okay, I want to set up the IP address to computers, but one computer present in my network is present in another building. मान के चलिए, so right now we are in campus 15. Okay, so to set up one IP address to a system, but now another system is present in maybe, let's say, campus 10. Okay, so which I want to assign an IP address, then I have to physically go to that. So but if I want to automate, I can remotely, by sitting at this location, I can also assign the IP address to the system. That means remote assignment is also possible. So if I go for automatic, so that means these are the advantages of assigning the IP address automatically instead of manually. So nowadays, so that's why nobody is mostly doing the manual type of assignment. Mostly the IP address assignment is automatic. Now the next question is, if it is automatic, then who will do that? When I say automatic, so there must not be any human intervention. That is how it is automatic, na? If there is a human intervention, so that is manual again. So I want to take away the human intervention. So as far as assignment of IP address is concerned, then who will do that? If human will not interact, will be not intervene in the assignment of IP address, then who will do that? Obviously, one software needs to be going to do that. So we need a software through which we could able to carry out the task, or that software can be called as a protocol. Okay, we need a protocol ultimately to carry out the assignment of IP address automatically. And who is that protocol? There are several protocols available, but the most popular protocol, that is DHCP. Okay, the protocol that we are going to discuss today is DHCP, is one of the most popular protocol who assigns the IP address to the system automatically. That's the first understanding, overall understanding I must have in mind why DHCP is needed behind the scene. Everybody got my point? Why DHCP? Along with this DHCP, some other protocols, let me also tell, so as to get a brief history of it. Okay. So now, first we talked about a protocol is needed to carry out the task of assigning the IP address automatically. So because I do not want the intervention of a human being. So as a part of these protocols, there are several protocols. So in early 80s, So there is a protocol called RARP, reverse address resolution protocol. Okay, this is called as RARP. Shortly, it is called as RARP, reverse address resolution protocol. Okay, so there is a protocol called ARP, address resolution protocol. So what the address resolution protocol does actually, so this protocol we are going to study in the MAC layer. So ARP does a conversion. If you give the IP address, if you know the IP address of a system, then ARP protocol is going to tell you what is the MAC address of the system. Okay, if you tell me what is the IP address of a system, this protocol, ARP, address resolution protocol, is going to tell us what is the MAC address of a system. Okay, and what a RARP is going to do, just the reverse of it, because RARP stands for reverse ARP, reverse address resolution protocol. What it is going to do, the reverse task of ARP. So if you give the MAC address of a system, he is going to tell what is the IP address of a system. So that's why, so if you tell the MAC address of your system, this RARP protocol is going to provide you the IP address from this particular system. Okay, that is how RARP protocol was used in 1980s. So which is no longer used because of the different issues. Okay, so actually one of the issues, just let me tell you in a brief. So what is the first issue or the most important issue in RARP? RARP actually works in the data link layer. It works in the data link layer. Okay, so if this protocol works in the data link layer, so then if I say, so this is my network, this is one network, this is another network. Okay, so in this network there are several systems present, in this system also there are several systems present. Now let's say this system wants to get what is the IP address of its own. Okay, it is going to start, you are going to start the system. Now by using a RARP protocol, so it's going to assign the IP address to here, okay, to this particular system. In this case, this RARP server must be present. This RARP server must be present within the same network, because if I'm using a data link layer protocol, if it is a data link layer protocol, so then this protocol can only facilitate the assignment IP address within the same network. But मान के चलिए, if this is a network, this does not have the RARP server functionality. RARP server functionality is present in this network. Then so a device from this network cannot able to get the IP address. So because there is no RARP server present inside this own network. So that's why this is the main difficulty what RARP protocol faced. So that means, so in order to get the IP address of a particular system, every RARP protocol or every RARP server has to run in each and every network. Every network के लिए एक RARP server आपको design करना पड़ेगा. So that's why, so this is not very robust. Okay, so that's why this protocol is no more used. Okay, this is a very earlier protocol people used to in 1980s. Then comes into picture the next protocol that is called as a BootP protocol. Okay, so that is a BootP protocol. Okay, this BootP protocol is used in 1990s. What is the advantage of this protocol? First of all, so the advantage is, so it has been working in the application layer. Okay, the problem that happened in the RARP, so that is, so every RARP server has to run in each and every network. Every network के लिए एक RARP server आपको design करना पड़ेगा. So because it is working in the data link layer, so problem has been eliminated in the BootP protocol by making it as an application layer protocol. So by making it as application layer protocol, what happens? So if application layer protocol, that means all the layers are present. Even if BootP, let's say there is a BootP server here. The BootP server is available here. There is no BootP server in this network, but still a device can make a query to this BootP server to get the IP address of it. Because with the help of a router, now it can able to talk to from one network to another network. And so it is facilitated only because this BootP protocol is using in the, I mean, running in the application layer. Running in the application layer means all the 5 layers of the stack is present. So that's why it can use the functionality of routing to carry out the task of assigning an IP address. But so as this protocol works in the data link layer, so no network layer functionality is available. So routing is not possible as far as this RARP protocol is concerned. So that's why BOOTP protocol comes into picture. So to get rid of the problem that is happened in case of a RARP protocol. But still, so whenever we talk about this BOOTP protocol do the assignment, static assignment. So whenever an IP address is assigned to a system, so that is basically static in nature. So that means always that IP address has to assign into that system. So that's why again there is a problem. So if let's say one system, let's say right now you have a laptop. Okay, now you are using Geo network. So whenever you are using Geo network, your laptop is given with an IP address. Okay, but you are changing now to let's say Airtel network. So will the same IP address so assign to your laptop, or a different IP address is going to assign to your system or laptop? Same or different? Same or different? Same hoga या different होगा? Different. So it will be different. But अगर मैं बोलूंगा, so whatever IP address I want, that IP address always must be assigned to my system. So then, so my BOOTP protocol is not going to work, because BOOTP protocol is going to only give a same IP address for every time to my system. Okay, so automatically it is going to give, but it is a static IP address. So that's why, so whenever you are mobile, whenever you are moving or you are changing from one network to another network, so this BOOTP protocol is not going to work. So that's why, so the latest protocol, which has been an extension of this BOOTP protocol, so that is called a DHCP protocol. And as the name suggests, DHCP, it is a dynamic host configuration protocol. It is a dynamic host configuration protocol. Okay, that means, so DHCP protocol tells that whatever BOOTP protocol provides, all the functionality I will provide. Along with that, I will assign the IP address dynamically. That's why it is called dynamic host configuration protocol. That means from time to time, the IP address of your laptop or system may change. There is no guarantee that, so always your laptop when you start is going to get the same IP address. That is what the DHCP protocol talks about. Has everybody ever observed this? When you start your laptop, have you ever observed? So is your laptop is always going to get the same IP address, or have you ever observed that so the IP address is changing sometimes as well? Is a DHCP protocol. So that's why DHCP protocol says that, so there will be a range of IP address. Out of this range, any IP address can be assigned to a system. So depending on the circumstances. So that's why there is no guarantee. So whenever you start your system or boot your system, the protocol behind the scene is DHCP. You are not going to get the same IP address always. Okay. So that's the bottom line as far as this protocol is concerned. This is a very high level overview I have just given in the background of DHCP. If anybody has any clarification, it supports all the functionality of BOOTP along with extra functionality, that is dynamic assignment of IP address. But it doesn't mean that DHCP does not provide static IP address assignment. So that means DHCP provide both the facility. It can assign the IP address statically. It can assign the IP address dynamically. So whenever you talk about assigning the IP address to a server, so the IP address of a server should be fixed. So in that case, it should go for using as a static feature of DHCP. But whenever it is going to assign the IP address to the end user, this is another router to this router. Let's say this is one network. This is another network. They are connected via several routers. Okay. And inside this network, there are several devices. There are several devices attached to this network. Okay. Now let's say, so every system has been assigned with an IP address. Every system is assigned with an IP address. Okay. But whenever, first of all, let's say I want to send a packet from this to this. Do I need to send the packet to the router? Yes or no? Yes or no? So that means whenever a particular packet is supposed to be delivered within the same network, packet needs to be routed to the router or sent to the router. Okay, but if I want to send a packet from this device to this device, so it must has to go to the router. So then the router is going to take the corresponding action how to forward the packet to the final destination. So that means there are two different scenarios. So if I think of, so whenever communication is going to happen in a network, so depending on the destination IP address, I have to take a decision whether the packet is going to send to the router or not. So how do you know? एक destination IP address को देख के आपको कैसे पता चलेगा? Can anybody tell me? Let's say this network is 192.168.1.1. So this system का IP address है 192.168.1.1, and this system's IP address is, let's say, 192.168.1.2, and this system's IP address is, let's say, 10.1.1.1. That's for example. Okay. So this is a different network, 192.168.1.1. This is 192.168.1.2, and this is 10.1.1.1. Now, so whenever you want to send a packet to, let's say, 192.62.1.2, you do not have to send it to router. But whenever you want to send the packet to 10.1.1.1, you have to send the packet to the router. How you decide? किसको देख के आपको पता चलेगा? So when I go network ID of the destination, मेरा नेटवर्क आईडी क्या है? सो मेरा डेस्टिनेशन का नेटवर्क आईडी क्या है? मुझे पता करना पड़ेगा. हाउ डू आई नो? कैसे, किसको देख के मुझे पता चलेगा? सो व्हाट इज माय नेटवर्क आईडी? किस इंफॉर्मेशन को देख के आई कैन? यस, सो आई हैव टू नो हाउ मेनी बिट्स आर नेटवर्क. दैट इज नेटवर्क प्रेफिक्स. मेरा कितना बिट्स नेटवर्क है अगर मुझे पता है, इफ आई नो दैट, आई कैन एबल टू टेल व्हाट इज द नेटवर्क आईडी. सो फॉर दिस आईपी एड्रेस, व्हाट इज द नेटवर्क आईडी ऑफ दिस आईपी एड्रेस, व्हाट इज द नेटवर्क आईडी ऑफ दिस आईपी एड्रेस. सो दैट्स व्हाई. So if you want to make a communication possible along with the IP address, I must to know the network prefix. Then only based on that I can able to decide where to send the packet. Are you getting my point? So that's why. So who will provide that? Somebody must provide this network prefix information to me now. So that is also provided by DHCP server. DHCP server also provides me the network prefix. So by looking into which, by using which, I can able to take a decision of, so while sending a packet to the destination. Everybody got my point? Now, next question. अभी बोला था, क्या बोला था? So if, let's say I want to send a packet so to this device, I have to send the packet to this router. But मुझे कैसे पता चलेगा इस राउटर को मुझे भेजना है? अगर if I want to send the so packet to this router, I must know the IP address of this router. अरे ये सर नो, अगर ये आईपी एड्रेस ऑफ द राउटर मुझे पता है, तो तब भी जाके मैं इस पैकेट को भेज पाऊंगा ना राउटर के पास, otherwise no. So that is beforehand, before my communication is going to happen, I must have the information of the router, so who is connected into that network, and that is called as a default router. Default router is the router who is connected to the network to whom I belongs to. So that is my default router, or in certain terms it is called as a default gateway. Okay, so that's why. So before any communication happens, I must have the information what is my default router IP address or what is my default gateway IP address, and who is going to provide that? DHCP again is going to provide this information. Okay, so otherwise no communication can possible if I want to make a communication in the internet. So I must have the network prefix. So I must have the IP address of the default router. So then another thing. So whenever you do a communication, are you providing the IP address? You are writing www.google.com. Are you here now? आप Google को so you want to download a packet from Google. You want to download a packet from Facebook. You are typing facebook.com, google.com. You are not providing the IP address of the destination. So somebody must be there who will provide you back to the IP address. Who is that? DNS server. Okay. So that means in that case you must first send your query. That is, so tell me what is the IP address for google.com before any communication is going to happen. But किसको भेजेंगे? अरे किसको भेजेंगे? किसको भेजेंगे पहले? Anybody remembers? अगर मुझे DNS query resolve करना है, so by sitting at my machine, so what is the address of the name server? That is my local DNS server. So that is how I should know what is the IP address assigned to the local DNS server of mine, so that if I need a DNS query to be resolved, I should send my request to the DNS server. That is the local DNS server. So who is going to provide that? Again, DHCP is going to provide that. Very, very important. DHCP is one of the most important protocol. So who is going to help a lot to us to make the communication possible. If there is no DHCP, so the protocol, communication is going to stand still. Okay, so that's why we have to understood. So first of all, so the basic functionality of DHCP, it provides the IP address, then it provides the network prefix. So then it provides the default router IP address, and then it also provides the IP address of the name server. With this, so basic information, I could able to make my communication possible. That is what is the functionality provided by DHCP. It depends. Okay, you may have a DHCP server in your local. It may have a different DHCP server, so maybe not present in your own network, maybe present somewhere else. So that's why ये figure बनाया था ना. If you look into this DHCP, यहाँ पर तो इसलिए बोला था ना. So in RARP, what is the problem? If you are using a RARP protocol, so every network must have a RARP server, which will going to help us to provide you the IP address for a given, MAC address. Okay, but with the development of this BootP and DHCP, they are not making it mandatory that each and every network must have a BootP server or DHCP server. So it is up to you. So depending on the requirement, you may have a DHCP server within your network, or you may not have a DHCP server within your network. Okay, so in both the case, so DHCP should work. Are you getting my point? Are you getting my point?
Yes.
How it is going to happen, we'll discuss. Okay, don't worry for that. Okay, but you understood that. So it is not mandatory. Okay, it may or it may not. Okay, so in what circumstances it may, or in what circumstances it may not. So when it is having the DHCP server within the own network, how the communication is going to happen, how it is going to get the IP address, and when it is not present, how it is going to get the IP address. Those details we are going to discuss. So what is a DHCP? What is the purpose of it? So what are the functionality provided by DHCP? Let's look into what are the various information that is to be present or exchanged. So during the communication between a DHCP client and DHCP server. So let's look into that. Okay. Before going to this DHCP message format, let me go to the operation. So then I'll come back to this. This slide I'll better protocol. Okay. Any protocol I have already told in my earlier classes. Always you have to think of what type of architecture this particular protocol is going to follow, because we know every application layer protocol follows maybe a client server, maybe a peer-to-peer, maybe a hybrid architecture. So here we have to understood what DHCP protocol is going to follow. So as I have already told, so that I have to maintain a DHCP server, and every machine who wants to get the IP address, so a DHCP client must be running in that to get the service from the DHCP server. So DHCP follows a client server architecture. Okay, that is the first part. Next part. So what type of transport layer protocol every application layer protocol is going to use, you have to understood. So here I say UDP is the protocol, so that is going to be used as the transport layer to make this communication. Can anybody think of what is the rationale behind using UDP as a transport layer protocol? So when you talk about UDP, as I have already told, so basically UDP is going to be used whenever the communication amount of information exchange is small. In that case, faster communication is a more concern than the secure than the reliable communication. Okay, so here if I look into this DHCP, what request I'm going to provide to the server? Tell me what is the IP address of, or give me one IP address to me. What the server is going to return back? The server is going to return back a just 32-bit information. So that is 10.1.1.1. That's it. This is the IP address you go and assign to yourself. So that means the amount of information exchanged between the client and server. So have the IP address assignment by using this DHCP protocol is very, very small. So that's why here fastness is a more concern. So rather than what? So reliable communication. And another most important aspect why UDP is being used. So when I go for the next stages, how exactly the communication happens, what are the various message exchange happen, then you also able to understood why UDP is used. Because So another important aspect, just try to understand this. So as far as this DHCP protocol is concerned, most of the packet communication is a broadcast. Can anybody tell me what is a broadcast? What is the difference between a unicast and broadcast? One communication, that is unicast. But when it is broadcast, so that means if I want to send a packet to everybody else in the same network, that is called as a broadcast. Okay. And so as far as DHCP is concerned, most of the communication, so that is going to happen to assign one IP address to a system is broadcast in nature. As it is broadcast in nature, so try to understood. So the protocol TCP does not support broadcast. TCP, transport layer protocol TCP does not support broadcast. It supports unicast. It does not support broadcast. Okay. But whereas UDP protocol supports both unicast and broadcast communication. So that's why this is another reason why DHCP protocol is using so this UDP as a transport layer protocol rather than TCP as a transport layer protocol. Okay. So this is the reason why so DHCP will use so UDP as a transport layer protocol. Another interesting thing. So this till now, जो भी protocol हम पढ़े हैं, so can anybody tell me? So whether the client runs on a well-known port or the server runs on a well-known port?
Server.
Server always runs on a well-known port. But this is the only application layer protocol that we are going to study right now, where both the clients and the server are going to run on well-known ports. Okay. So what is the well-known port that server is going to run? 67. 67 is the well-known port. So where the server is going to run. 68 is another well-known port where the client is going to run. Why it is required? So after some time, if time permits, I will discuss today, or maybe in the next class I will discuss. Okay. Why there is a requirement of so running in a well-known port? Client को क्यों मुझे so एक well-known port में run करना पड़ रहा है? So that we have to also understood. Okay. But so what we understood out of this, DHCP uses a client server architecture. So it uses that UDP as a transport layer protocol, and the so well-known port where the server is running is 67 and the well-known port where the client is running is 68. Okay. So these are so the basic operation what a DHCP is going to follow. Okay. But what I have told here, so because most of the communication happens in a DHCP is broadcast in nature. So as far as this broadcast is concerned, one concept you have to understood here. So that is broadcast are basically of two types. One is called as a limited broadcast. Other one is called as a directed broadcast. There are two types of broadcast you have to understood if I want to understood the DHCP operation properly. So broadcast can be of two types. One is limited, one is a directed. What is a limited? What is a directed? Let's try to understood. Okay. So here let me just draw a diagram so as to, because of lack of space, I'm just putting it here. Okay, so these are the two networks. So both are connected via a router. Okay, so these are the devices present. This diagram most of the time I write, so don't be bored with this diagram, but one of the most important diagram. Okay, my diagram is very rough. Okay, I don't have a beautiful handwriting and writing, so please bear with me. Okay, so what happens when I talk about this? So this is one network. This is another network. Let's say my requirement is to go and send a packet from this to all within the same network. This is one requirement. Try to my requirement. My pehla requirement kya hai? So this packet wants to send a packet to everybody else in the same network. This is one requirement. Second requirement, I want to send a packet to everybody else in another network. That is another requirement. Try to understand. In one case, I say, so I want to send a packet to all others in the same network. In another case, I say, I want to send a packet to all others in another network. So what I have to go and use? So the destination IP address in these both the cases should be a broadcast IP address. Broadcast IP address facilitates me to send the packet to all others. So in the network. Okay. But now the question is, when I want to send to everybody else within the same network, I have to use the concept of limited broadcast there. Okay, so limited broadcast concept will be used. So whenever you want to send a packet to everybody else within the same network, try to understand. So then what is a In this second scenario, if this system wants to send a packet to everybody else in the different network, then limited broadcast is not going to help. We have to use a directed broadcast. You have to use a directed broadcast concept. Okay. So now, so what should be my destination IP address? Agar may, so now I want to send a packet to all others in the same network. So as the destination IP address will be a limited broadcast. So remember, as far as limited broadcast is concerned, always the IP address is 255.255.255.255. This is, if someone is having a destination IP address, this means, so this is a limited broadcast. That means this packet will be broadcasted or sent to everybody else within the same network. So as the originator of the packet. Okay. So that is what is the destination IP address. But now, if I want to send a packet to this network all, so it is a directed broadcast, then what should be the destination IP address? My destination IP address should be the broadcast IP address of this network. Let's say, for example, the network ID of it is 192.168.1.0. This is my network ID with a network prefix of 24. Try to understood. 192.168.1.0/24. This is my network ID of this network. And the network ID of this network is, so let's say 10.1.1.0/24. Let's try to understood like this. The network ID of this network is 10.1.0/24 and the network ID of this is 192.168.1.0/24. Now, if I ask you, can you broadcast IP address of this network? So if I want to send a packet, so from my system to, so this, all other systems of this network, then my destination IP address should be a broadcast IP address. So that is a directed broadcast IP address, and directed broadcast IP address is nothing the broadcast IP address of this network. So my destination IP address should be 10.1.1.255. Are you getting my point or not? Anybody has any doubt on top of it? What is a broadcast IP address? So I mean limited broadcast IP address. What is a directed by broadcast IP address? In what scenario? So my destination IP address should be a limited broadcast IP address. In what scenario? My destination IP address should be a directed broadcast address. If it is a limit, we're going to use the directed broadcast. But you have to understand the concept. I have just introduce the concept of directed broadcast for your understanding. So always DHCP during the operation, it is going to use the concept of limited broadcast so as to send the packet to everybody in the same network. Okay. So now, so going back to this. Okay. Once you understood, so this basics. So now let's look into how a DHCP message looks like. What are the various information going to be exchanged as a part of DHCP message? Let's look into that part. Okay, look into here. So this is the header structure of a DHCP message. So the first information is the OP code, operation code. Okay, what a operation code? Operation code can be either a request or a reply. That means your DHCP message can be either a DHCP request message or a DHCP reply message. These are the two only possibility. So as far as the message, so different types of message in DHCP is concerned. So it is going to specify H type. H type is hardware type, not header. It is not header. It is a hardware type. What is the hardware type? Why it is necessary? Because so DHCP is going to work upon any type of hardware. The hardware may be a Ethernet hardware. The hardware may be a Wi-Fi hardware. The hardware may be a token ring hardware. So that means for different types of hardware, so the same DHCP protocol is going to work. Okay, in the application layer, the DHCP protocol can provide the service to different type of data link layer devices. That is the hardware. Because when you talk about the hardware, it is mostly in the data link layer and the physical layer. So that's why. So the hardware type has to be specified. And so in our case, so normally it is Ethernet. Because we want to do a wired communication, it is Ethernet. If we want to do a wireless communication, this is a Wi-Fi. Okay, so this is the hardware. So if it is a hardware, then different hardware has a different length. Length means what? So if I talk about Ethernet, so every Ethernet is associated with a unique address. So that is called as a MAC address. Okay, as we are saying now, we have already told. So one is the IP address, that is logical address assigned to a system, and another another address that is called as a MAC address, which is a physical address. So that is assigned to the NIC card of your system, and that is fixed. You cannot change the MAC address, but you can change the IP address from time to time depending, because that is logical. Okay, that is configured through a software. But when you talk about MAC address that is assigned to the hardware, so that is during the manufacturing of that particular hardware, the manufacturer has assigned the address to it. You cannot change later on. That is what is the MAC address, that is the hardware address. And so the MAC address is a 6 byte long. The MAC address information, that detail we are going to study actually in the data link layer. Okay, so it is a 6 byte long. So that's why the H length will be, hardware length will be 6 here. So depending on the different hardware may have different length or the address, so which is uniquely representing that hardware. So that's why that length of the hardware must be specified in the next one. Okay, so hardware type and hardware length. Then hop count. Next one is the hop count. What is the hop count? So we already understood hop count. That is TTL in the network layer header. Can anybody remember what is the use of TTL? Time nice answer. So when you talk about whenever you are going to send a packet because of wrong routing, if the packet is going to loop around, so then it is a wastage of resources and bandwidth. So in order to stop those things, so here the introduction of TTL was there in the network layer header. Similarly, this hop count is another feature. So that is present in the DHCP message format, which going to tell how many maximum hops your DHCP message can be forwarded to get the service from a DHCP server. Okay, so this is the hop count, and normally it is set as 16. Maximum hop count is 16. So through which your message can be transmitted, so to get the service from a DHCP server. Okay, so now this is the hop count. Then transaction ID. What is the transaction ID? Transaction ID. So whenever you are, so let's say starting for a DHCP request, let's say you are here, you are sitting here, your DHCP server is sitting somewhere else. This is sitting in another network, and also another device. There are two devices sending DHCP request message to the server, and DHCP server has to give reply back to both of them. Yes, but when the reply is coming, how to know which reply is meant for this one, which reply is meant for this one? So that's why, that is where the transaction ID is going to help me. That means every communication happens between the client and server is provided with the same transaction ID. Same transaction ID. So that means if transaction ID is 1001 for this client, for all communication happens between this client to this server, as far as DHCP, so IP address assignment is concerned, all the request and reply message is associated with the transaction ID of 1001. If I talk about this, let's say for this it is different one, so 1002. So in that case, all the communication happens between this device and this server, so we will associate it with a transaction ID of 1002. By looking into this, actually we could able to segregate, so this particular message comes from server to which particular client, we could able to segregate, so by using this transaction ID. Because till now no IP address is assigned, na? So we are trying to get an IP address, we don't have any IP address, so how to know? So this packet, this reply is for which particular machine or which particular client. So that is the transaction ID is going to help us to identify a reply message coming back from the server is supposed to be for which particular client. That is how it is going to help us. Okay, that is how it is basically going to help us for carrying out our task. Okay, you understood the transaction ID. Now, time elapsed. What is this time elapsed? The time elapsed is basically how much time, so from the time you have started. Okay, you have already started the machine, booting the machine. Okay, how much time has elapsed, so till now? So that information is going to be captured inside this time elapsed field, so to know how much time since you are still waiting for getting the IP address. So this is a field which is going to help us. Then another one is called as flags. So what is this flag? So plug is basically, actually it is 16-bit. The plug is 16-bit, but actually out of the 16-bit, only 1 bit is used. Rest 15-bit as reserved, not used so right now. So what is this 1 bit? So which is used? So that 1 bit can be either 1 or 0 to indicate that whether the communication is a broadcast communication or it is a unicast communication. Okay, because I told na, so in DHCP communication, to get the IP address, most of the communication is what? Broadcast, but still there is a possibility some messages may be unicast. So in order to segregate which messages are unicast messages, which messages are broadcast messages, because why it is required? Can anybody tell me why? So I cannot. So during any normal IP communication, do I use a flag bit to indicate whether it is a broadcast or unicast? No, not. But why it is required here? Because I don't have any IP address of the client. So by looking into which I can able to tell whether it is a unicast or broadcast. So that's why. So by looking into this, so field we could able to decide whether the communication is a unicast communication or a broadcast communication. So these are some by chance we are reading it here in the network layer. Because if I studied this DHCP protocol, so in the application layer, so while studying the protocols, so because lot of concepts is used inside this DHCP, which is related to the network layer. If I don't have the minimum basic functionality of network layer or transport layer, we cannot able to understand this protocol how it works. So that is the rationale why we are studying this DHCP protocol in the network layer, even if it is a application layer protocol. So don't make it a mistake. So DHCP message we are studying in network layer means it is a network layer protocol. It is actually application layer protocol. But for better understanding of this protocol, we are bringing down this particular protocol to the network layer. So for our understanding of clarity of understanding. So after knowing some concept of transport layer and network layer, you could able to understood this protocol. ID is basically used to uniquely identify a particular message exchange within the same session. Okay, and time elapsed. So how much time has been elapsed since the booting process has been started by the system. Then plugs. In these plugs, there are 16 bits, but actually only 1 bit is useful for us. The rest 15 bits are unused. Okay. So what is the significance of that 1 bit that is basically used? So that bit value either can be 0 or 1. It can be 0, it can be 1. Okay. So this is going to inform whether the message is a unicast message or a broadcast message. Okay. So that is basically this flag bit is going to be helpful for us. Now coming to the next important points. Client IP address. See, so whenever the client is going to know what IP address I am supposed to be assigned, then it can put or populate this IP address with the client with its own IP address. That is called as a client IP address. But normally, maximum cases, client does not provide anything in this client IP address. That means it provides a value of 0.0.0.0. So whenever the client does not know what is the IP address, that is the normal case. So in those scenarios, client IP address will be populated by the client at the client side as 0000. Okay, because that means I do not know what is the address of mine. Your IP address is basically this. Your IP address field is going to be populated by the server. Whenever the client requests for an IP address, at that time server is going to provide an IP address. So whenever the server is going to provide an IP address, it is going to be populated in this your IP address field. In the your IP address field, whatever IP address server is responding back to the client, so that IP address client can be assigned to carry out a task. So that is populated by the server in the your IP address field. Okay. Then the server IP address. Obviously, so when the server is going to respond, server may go and put the IP address of its own in the server IP address. Okay. So or whenever the client knows what is the server IP address, at that point of time also it can go and specify this server IP address. Now, so gateway IP address. Gateway IP address is basically going to be useful. So whenever there is a concept of relay agent, I'll talk about that. So there is a concept of relay agent. Relay agent. Okay. We'll talk about that. So, but normally, so this gateway IP address is again set as 0000. Okay. So whenever basically the relay agent concept is being used, at the relay agent, so this gateway IP address is going to be populated. I will tell exactly in what scenario this relay agent is required and how this gateway IP address is going to be populated. But for the time you understood, so gateway IP address means actually the router IP address. Okay, and that is so by default normally in most of the cases it is going to be 000. Then the sorry. Then the client hardware address. Client hardware address is basically so whoever is going to generate this DHCP message. So whatever is the MAC address, if it is Ethernet, whatever is the MAC address, that MAC address is going to be populated here. So that so by using the MAC address at the server end, if there is a mapping between the MAC address to IP address, then you can fetch the IP address based on that and client provide it. So that is so why the client hardware address is being populated and sent to the server. So from the client end. Okay, and then server name. What is the server name? It may happen. There may be multiple DHCP server present in a network to provide the service. Whenever so the size of the network is very huge, it may happen more than one network, more than one. I mean DHCP server is going to be there in the network to provide the service. But if a client specifically wants to get the service from one specific server instead of other, so then he can go and specify what is the name of the server. Okay, the name of the server can be specified by the client. So if he desires to get the service from a specific server, in that case, the server name, the server needs to be specified. And also in that case, actually what happens now? So whenever you talk about DHCP, so what happens? So when you start your computer, boot your computer, first of all, first of all, your server gets an IP, your client gets an IP address. Once your client gets an IP address to the DHCP protocol, then it is going to download the boot file to start the computer or to start the operating system. So that means what boot file from which you want to start the operating system. If you want, you can go and specify the boot file name here. If you do not specify any boot file name here, the server is going to provide a default boot file. But if you want a specific boot file, so from that you want to start your computer or boot your computer, so then you need to mention the boot file name. So from which server and which boot file you want to download, so that is going to be used for starting your computer or booting your computer. So that is where this boot file concept is going to be helpful. So where the client may specify the boot file name if he desires a specific boot file to be used for starting his computer or booting his computer. That is the purpose of this boot file. Okay, and then options actually, so this is again optional. You may not. Okay, depending on the requirement, you may go and add some option. So let me tell about one important option. So in one of the important option is this 53. That means the option looks like this. So tag length value, the parameters going to be populated in this option, which is optional, having a tag length value. What is the tag? Tag is a specific value. If it is 53, that means it is going to tell what, because initially what I tell, either DHCP message can be of two types. One is a request, one is a reply. But actually, so there are several request messages as well. There are several reply messages. So how to know what exactly, so which particular request message is going on at this moment? So then in that case, this option field is going to help me. So where this tag is 53 means it is a DHCP exact message. कौन सा DHCP message आ रहा है, it is going to specify. So then length is 1 byte. Okay, and the value is one of these values. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 actually DHCP messages exchanged between the client and server. So from time to time, depending on the requirement. So that's why, what is the value? So if it is a DHCP discover message, the value will be 1 here. If it is a DHCP offer message, the value will be 2 here. Like that, which exactly message right now is going on. So that is can be found out from this tag length value field. So which is present in the option setter. This is one of the important options. There are other options as well. We are not going to talk about much about this option. Other options only we are going to concentrate on this
So tag length value where, so this tag 53 represents, so which type of exactly DHCP message is right now going on, so as far as the communication is concerned. Okay, so this is just a very high level client. Okay, what happens, let's say this is a DHCP client. Okay, this is a DHCP client. Now start the machine. So he wants to get an IP address. So now he has started the machine. So initially what he is going to send, he is going to send a DHCP discover message. Okay, so now the client starts with a DHCP discover message. So with the, so some of the important parameters is shown here. So transaction ID, as I have already told you, transaction ID is unique for all the message exchange going to happen between this client and the server. Okay, so let's say it is 1001. That is randomly generated at the client end. Let's say it is 1001. Then there is a lease time. Okay, lease time. So lease time actually we'll talk about. So forget about at this moment. So then client address. So as I am the client and I want to get an IP address, I do not know what is the client address. So it is left out. Okay. So then your address is not filled by the client. It is going to be filled by the server. Then server address, I don't know the server address. Okay. I don't know who is the DHCP server. So what I'm going to do as a concept of it, I have to do a broadcast. And yes or no, if you remember the concept. So I do not know who is the, so because if I look into the scenario, just I'm putting a scenario so that you can visualize. So let's say here, this is my machine who wants to start. These are several machines available. And this is one of the server, DHCP server available inside this network. Okay, this is the network. Try to understand like this. This is a network where various machines are available and there is a DHCP server configured in this particular network. But so this, whenever you start, let's say you are here, this is your machine, you start your machine now. So whenever you start your machine, you do not know who is the DHCP server so present here inside my network. So what you are going to do then? So you are going to broadcast a message to, that is this DHCP discover message. You are going to broadcast to everybody. So when everybody is going to get it, whoever is the DHCP server, he is going to accept this message or they are going to reject this message. So that's why, so as you do not know who is the DHCP server, what basically you are going to do, you are going to broadcast. Okay, so these are some of the important parameters shown as a part of application layer. Okay, so in the application layer of the DHCP message, what are the information to be populated? These are some of the important, I say. Okay, and then so next to it is the transport layer. In the transport layer, what I have told, so the destination port number, most important, this is the most important information. Destination port kiska hoga? Server ka. I have already told the DHCP server must run on a port number 67. And I already told, so here the uniqueness is DHCP client is going to start on a specific port number, that is a well-known port number 68. So that's why the source port number here is 68 and the destination port number here is 67. Okay, and then the network layer. This is the network layer. Most important information populated in the network layer. Source IP address. Till now the client has not gotten an IP address, so it is 0000. So then destination IP address. So किसका होगा? Server का. मुझे server का IP address पता नहीं. क्या करेंगे? I have to specify the broadcast IP address. Can anybody tell me what type of broadcast IP address it is? I have already told there are two types of broadcast address. Anybody can tell me what are the two types of broadcast? At point of time, so server receiving this DHCP discover message, what he is going to do? He is going to return back a reply message. This is a reply message. This is a request message. This is a reply message. So what is going to do? So it is going to reply to DHCP offer. He is going to provide an offer to you. Okay, these are the IP address, or this is the IP address I offer to you. You can assign which. Okay, so that's why now the DHCP server is going to provide an offer. But the transaction ID will remain the same as I have already told. So 1001. Here comes the lease time. This is very important. Try to understand. Lease time is 3600. What does it mean? Actually, lease time is basically specified in seconds. Okay. So that means whenever it is saying lease time, that means so whatever IP address I am offering to you, that is valid for 3600 seconds. That means 1 hour. So beyond that, so that particular is having no significance. That means, so that IP address is no more going to be used by you after 1 hour. Okay, so that is the lease time. Lease time, because whenever a IP address is given to a system, the IP address is given for a specific period. Once the lease is going to be, so I mean expired, you may renew that particular IP address. Okay, renew assignment of the IP address. I'll tell just after this slide. Okay, just for the timing, you understood lease time is the time for which the IP address is valid. Okay, so that is specified by the server in the DHCP offer. Then client address has not to be populated here. So but server is going to offer one IP address to the client. Where it is going to populate? It is going to populate in your address. So that means server is now saying to the client, this is your IP address, so I am offering to you. So that's why in your address field, server has populated 181.14.16.182. That means this is the IP address I'm offering to you. So you may assign this IP address to your machine. Okay, and then this is the server IP address, what server is replying back. Okay, this is the IP address of the server. Server is providing this to the client. Okay. This is some of the important application layer parameters is populated by the server. So ultimately, so if the server is going to send back the information to client, so source port number becomes 67 and destination port number becomes 68. So source port 67, destination port 68. Okay. Now in the network layer, the source IP address is the IP address of the server. So this is the IP address of the server 170. So it is populated here again. So now the destination IP address will be a broadcast. Can anybody tell me why the destination IP address is a broadcast here? In these circumstances, till now, so the client has not been assigned with an IP address. So that's why the server has to again send to everybody else. Okay. So that means everybody else in the same network. So that's why the destination IP address is again a limited broadcast IP address. Okay. Once the is meant for me, which is not for me. Okay. Now, once the DHCP offer message is being received at the client end, what the client is going to do? The client. So, abhi ek offer mila hai. It may happen. I have already told. It may happen. There may be multiple servers. There may be one more server. There is. You can't say that. So only one server is available in a network. It may happen. In reality, there may be multiple DHCP server in the same network. It may happen. Even there is not a single DHCP server in a network. I'll go into that scenario. Okay. So, but for the time being, you understood there may be multiple DHCP server available to provide the service to you. In that case, it may happen. So, whenever you are going to broadcast this DHCP server is going to get it. This DHCP server also going to get your request. So, whenever both the DHCP server are going to get the request, so both are going to trying to provide you an offer, na? Yes or no? So this DHCP server is going to provide you an offer. This DHCP server may also provide an offer to you. So that's why when more than one DHCP server providing an offer, like let's say you are going for placement. Whenever we are going for a placement, so it may happen. So more than one company are going to provide the offer. You do well in all the examination, all the interviews. So multiple companies may provide you the offer. But when you accept it, so we have to only accept one offer, na? You can't accept multiple offer, right? So similarly here, so more than one DHCP server can provide you the offer of an IP address to be assigned to your system. But ultimately, you have to choose one among them. So that's why, so you have to send a DHCP request message. Okay, saying that, so what IP address you want to assign. Okay, so that means now what he's saying this, look into this. So he is going to send a DHCP request message. In this transaction ID will remain the same and the lease time is populated as per the lease time provided by the server. Now see the client IP address is populated with this IP address. That is now client says that I am interested in assigning this IP address to my system. Okay, so that's why he sent a DHCP request. So saying that this is the IP address I like to assign to my system. Okay, so when it is going to tell that, so here the server IP address, so is this. That means what is the server IP address signifies here? So this IP address provided by this server. This IP address, because I say now multiple server may provide the IP address. So which servers offer he is accepting, that is the server IP address is specifying here with the IP address what he likes to assign to a system. So these are the important information he is populating. Then obviously source port becomes 68, destination port becomes 67. And look into interestingly this source IP address is खुद का own IP address. That is, this is what he wants to assign. Okay, and so destination IP address, look into the destination IP address. Why it is broadcast? Can anybody think of? Because he already, so that means similarly here, so whenever the DHCP request is being sent to, so it has to send to everybody, so that means all the servers so present maybe in the network, so that so whoever has so given this offer, he will able to know, okay, my offer has been accepted, and whoever offer has been rejected, he also may be able to know that my offer has been rejected so by the client. That also very, very important, so that IP address can be provided to somebody else by the server to any other client. Okay, that's why so this destination IP address is a broadcast IP address, not a what unicast IP address. Then once the so DHCP request is given so to the server, what happened? So let's think like this. Let's say a company has provided an offer. Okay, multiple company has provided offer. You have accepted one offer. Okay, so but maybe so whenever the company has provided the offer, they have given you a deadline. So you have to respond. So if you accept this offer by this date, but unfortunately you have crossed that deadline, and you are now accepting the offer after the deadline, and you are sending a request to the company saying that I accept your offer. In that case, the company, even if you accept the so offer, company may so what decline to so observe you. Company may so not accept your request at that point of time. So there are various scenarios. So I'm just giving one example simply. So that's why it may happen even if the company, even if the DHCP server has provided this offer to you and you have accepted this offer, but after certain period of time, when you are sending this so message to the server, I mean the DHCP request saying that so this IP address I would like to assign to me, so it may so saying that I cannot assign this IP address to you at this moment because I have already assigned, or I have already assigned this particular IP address to somebody else. So that's why in that case, so the DHCP server may send a ACK message or may send a NACK message. If whatever IP address so you are saying that I am interested in assigning to my system, if the server is going to have no problem in giving this particular IP address to you, the server is providing with a DHCP ACK message. But at that time, so if that IP address is already given to somebody else, so then okay. So what I'm saying, so whenever the DHCP server is receiving this DHCP request message, it may accept the final offer or it may reject you also. So that's why whenever it is saying that I am yes, so this IP address now it can be assigned to you, then it is going to send an DHCP ACK message. But at this moment, if this IP address is already given to somebody else, so by the server, so then he is going to send a NACK message. Okay, depending on the circumstances at that point of time, so DHCP server is going to send so either a ACK message, that is a DHCP ACK, or it may going to send a NACK message, that is a so negative acknowledgement. So in this case, if I look into this, so this is the transaction ID as I have already mentioned. So then the lease time, same client IP address, not needed to be sent by the server. So this is the your IP address confirmed. So this is the server IP address. Okay, and this is the source IP address and destination IP address. Sorry, destination port number is somehow left out here, so wrongly. Okay, destination port number. So then source IP address is the IP address of the server, and the destination IP address is the broadcast IP address. Can anybody the so IP address of the server offer? So, but it may happen if the so server is going to reject it, so or accept it, that other server may also know it, so that accordingly they can go and take the respective action on top of it. So that's why. So it is again a broadcast. So to make this communication possible. So if I look into a whole scenario, so first DHCP discover message is going, and then the DHCP offer message coming back from the server, and then so DHCP request here. So see, so whenever the client is going to send a DHCP request, also at this point of time, the client may provide another request message that is called DHCP decline. Decline. There is another message I have already shown you earlier. So that is DHCP decline. In what scenario? So instead of sending a DHCP request message, the server wants or server sends a DHCP decline message. Let's try to understand. Sometimes the client wants a specific IP address to be assigned to him. He do not want, so or maybe sometimes, so the client want a range of IP address. Within this IP address, 1, 2, 3 or 4 IP address, anyone can be assigned to me, it is okay. But anything other than that, I do not want to accept those, or I do not want to assign those IP address to my system. So whenever a IP address that is offered to so the client by the server, but the client did not want that IP address to be assigned to his system, in that case, so he can go and send a DHCP decline message, so the server could able to know, okay, so sorry, so client is not interested in assigning this IP address to him, so I may go and generate another IP address for him to provide. Okay, in that case, so the client may so generate a DHCP decline message as a, so the response to DHCP offer message by the server. Okay. Okay, so along with this, there are two messages we talk about. If I look back into this, so we talk about DHCP discover, we talk about DHCP offer, we talk about DHCP request, we talk about DHCP decline, DHCP arc, and DHCP NAC. So there are two remains. One is DHCP release, one is DHCP inform. Okay, so these two information. So let me be DHCP release. I'll just go and tell after one more slide. But look into this DHCP inform. So what this DHCP inform message talks about. So let's say I have already assigned with the DHCP IP address. DHCP server has already provided the IP address to me. What I have told in initial class. So getting the IP address is not sufficient enough for me. That means along with the IP address, I need network prefix. Along with the IP address, I need a gateway router IP address, default router IP address. Along with the IP address, I need a DNS server IP address. So that's why how I'm going to get it. So these messages doesn't inform. So those information, those are these messages what we have already discussed. So they are just involved in assignment of IP address. They are not going to provide this. So network prefix, DNS server IP address, default router IP address. So I have to get it by using a particular message that is called DHCP inform. That is, so when the client sends, after getting the IP address, the client sends the DHCP inform message to the server. So then DHCP server is going to provide this information or extra information back to the client, so that now communication can possible. So DHCP inform, with the help of DHCP inform message, the client can request extra information which are required for making the communication along with the IP address. That is what is the use of this DHCP inform. So now going to DHCP release. So let me go for this finite state machine, so that I can able to explain you. So what are the various DHCP release scenario? So let me go and talk about it. Is there any doubt on top of what we discussed? It init state. Okay. So initially the DHCP client present in the init state. Okay. So being in the init state, what he's going to generate? He's going to generate a DHCP discover message. That is the first message, na? So in order to get the IP address, so the client is going to generate the DHCP discover message. Now, so the client DHCP discover message generated by the client. Once it sends the DHCP discover message to the server, thereby going into a state called selecting. Now it goes into selecting state from the init state. Being in the selecting state, so what the client is going to receive? The client is going to receive a DHCP offer. Yes, the server is going to send a DHCP offer, client is going to receive it. Once the DHCP offer message is received by the client, now the client is going to select one of the offer. There may be multiple offers, now, as I have already told. So client is going to select one of the offer, and as a consequence of it, he is going to generate the DHCP request on behalf of it. Based on the offer he has selected, out of multiple offers he has received, so now he is going to generate a DHCP request message on top of it. So then thereby going into a state called requesting. From selecting, it is going to a state called requesting. Okay. So now being in the request, what happens? So now he is in requesting. So he may receive a DHCP arc. So whenever the server has sent a DHCP request message, he may receive a DHCP arc. He may receive a DHCP NAC. There are two possibilities. So being in this requesting state, a client may receive a DHCP arc message, or so the server may generate a DHCP NAC message towards the client. If the DHCP ACK message is received, that means so server is giving a green signal. Now you go ahead. So you can go and assign this IP address to a system. Now So thereby the client is going to a state called bound. That means the IP address is now bound to that particular system. Once the DHCP ARC finally coming from the server. But if the DHCP NAC is coming, now that IP address cannot be assigned. So that's why if the DHCP NAC is coming and receiving, then it is over again, go back to the init state and so do the same procedure once again. So the client so goes to the init state and go and repeat the same procedure of discovering the IP address once again by sending a DHCP discover message from its own end. Okay, but once it is IP address is assigned and the so client is in bound state, as I have already told. So every system is given with a lease that is the IP address provided by the or offered by the server. So has a lease time. After that lease time is over, that IP address cannot be anymore assigned to that particular system. So that's why what the client is going to do, client is going to check from time to time, is the lease time is going to expire. Okay, so while checking, he found that 50% of the lease time is expired already. Let's say it is given with 1 hour. Now 30 minutes has already gone. So that's why in that case, again, he's going to so send a DHCP request for renewing that particular lease. Okay, so he wants to renew that particular lease. So when the 50% of the lease time is expired, so the client is going to generate a DHCP request message to renew that particular lease. Okay, so it is going to renew, so that means now it is going to the renew state. Okay, so once in the renew state, what may happen in the renew state? So the server may send a DHCP request. Okay, go ahead. So the IP address is renewed for you. Okay, that means lease time is extended again. So that's why DHCP ARC. So being in this state, renewing state, if he is receiving a DHCP ARC from the server, now he again go back to the bound state. Okay, like that. So sometimes it may happen. He's in renewing state. He has given a request to the server to renew, but server is not responding. कभी-कभी होता है because of some reason server doesn't respond to your DHCP request message to renew your offer. Okay, in that case, so again once again he is going to check the lease time. If the lease time expired is 87.5%, अगर मान के चलिए 87.5% expired हो गया, but still now so the server is not responding your DHCP request for renewing. Again, once again you are going to send or generate one DHCP request. Okay, so thereby going into a state called rebinding. Again in the rebinding state, after you send a DHCP request, it may happen server may send you a DHCP ARC at that moment. If he is sending a DHCP ARC at that moment, you again go back to bound state. But if the server does not respond with a ARC, he respond with a NAC. No, he do not want to renew this IP address with you. So in that case, he is going to provide you a NAC. So in this case, again you are going to go back to init state, and the whole procedure is going to be started again. But once again look into, so whenever you are in bound state, that means already the IP address is given to you. Let's say the IP address is valid for let's say 5 hours. Okay, but after 4 hours your job is over. After काम खत्म हो गया, you want to shut down the machines. Okay, that means that IP address you want to release, na? so that IP address can be given to somebody else by the server. So at that point of time, if you do not want that any IP address, if the client do not want that IP address anymore, or he may be not interested in this IP address anymore, or his work is over because of some reason, so he do not require this IP address again. So in that case, he can cancel the lease. So by generating a DHCP release message to the server. Once the DHCP server gets this release message, so that IP address is released, and that IP address can be assigned to somebody else, and thereby the client is going into init state, and whenever he wants again the IP address, he has to go through all the whole procedure once again, so as to go and assign the IP address to its own system. Okay, so this is how a client changes from one state to another. So while assigning the IP address, or already the IP address is assigned, while renewing the IP address, or the IP address is already assigned, he wants to cancel the lease. So depending on the circumstances, so now the client can goes from various state, one state to another state. So during the whole procedure of assigning the IP address, and renewing and releasing the IP address in the DHCP. So what I have already told. this is a network. This is a network. These are the various machines. Okay, and this is a DHCP server configured. Okay, this is a DHCP server configured here. Now this is one system wants to get the IP address. Okay, so when it gets to IP address, as I have already told, he has to broadcast. He has to broadcast to everybody. So at that point of time, as already a DHCP server is configured in this network, so there is no problem absolutely. But let's think of another scenario. Let's think of another scenario. This is another network. There are several devices available here, but there is no DHCP server configured in this network. It may happen. Okay, there is no DHCP server configured here. Now, so this machine wants to get an IP address. What he's going to do? He's going to do a broadcast. That is a, so what? What type of broadcast? If he knows the IP address of the server, he can able to make a redirect, directed broadcast. And also, if you already know the, IP address of the server, there is no need of broadcast again. Unicast message is going to help me, na? अरे अगर मुझे destination का IP address पता है जिसको मुझे message भेजना है, so do I need a broadcast? I don't need any broadcast, na? In that scenario, what I have to do? I have to go for a unicast. So that's why that is the directed broadcast is never used by. Directed broadcast is never going to be used by. Directed broadcast is never going to be used by this particular what? So DHCP. So always it is going to use the limited broadcast IP address kind of concept. So in that case, look into if it is a limited broadcast, he is going to do. So nobody is a what? So what? DHCP server. If nobody is a DHCP server, how he can get the IP address? It cannot. So that's why I always remember. So as I am saying that DHCP server is present in a different network, there must be a router to connect. If I want to make a communication from this network to that network, obviously there is a router in between. And whenever you broadcast, so your broadcast information is going to be get by the router as well. Router is going to get your information. So when the router is going to get your information, if the router has supported with the functionality of relay agent, so then what the router is going to do? Router is going to broadcast your message to other network. In that case, when the router is going to broadcast your message, if he behaving as a relay agent, so then all the different machines present in the network are going to get it, so that the DHCP server who is sitting in another network is going to get your information, and now that DHCP server can send you back an offer so that you can go and get it. Are you getting my point? So that's why. So it is not mandatory to have the DHCP server in your own network where you are present. You are least bothered about. So whether the DHCP server is present in your network or not, you are always going to do a limited broadcast. Whenever you are going to do a limited broadcast, if there is no server, so your router has to be configured by the what? Network administrator को ये पता होना चाहिए, नहीं तो नहीं होगा. So network administrator knows that there is no DHCP server present in this network, so he must have configured the default router with the relay agent concept, where so whenever a DHCP broadcast information is received from the client, so the router is again going to forward it to the respective server, so that your DHCP server can get your request and accordingly reply you back so as for assigning an IP address to you. This